Now let's look at the second question. This question was asked in Amazon, I guess. Yeah. So given a binary sorted matrix A of size n cross m, find the row with maximum number of ones. Like there are two information given to us. First, the matrix is binary. Second, it is sorted. So let's look at it. Binary means your matrix only consists of ones and zeros. So all the values in your matrix are either one or either zero.
Or zero. Okay.
Yeah. And the second point is that the
Okay.
matrix is sorted. That means all the rows are sorted. So we can only have two things, either zero and one. So we cannot have any row like this. It would only be sorted. So we cannot have zero after one in any row. Zero can be like this, right? Can be like this. So this is a valid matrix. But if this is not a valid matrix, right? This is an invalid matrix because it is not sorted. Rows are not sorted. So all the rows would be sorted. Okay. Now what it is asking us is we have to return the row which has the maximum number of ones. So in this case, it would be fourth row with index 3, right? It has the maximum number of ones. Okay. So let's try to make some observations here. Looking at the problem, can you give me any solution? Like it does not need to be optimized right now. Any solution that you can think of? How can we give the row with the maximum number of ones? We just have to return the index of the row.
A very silly approach.
Yeah,
But
any approach would work.
I can declare four variables and I can count every once in every row and I can compare all those four
Yeah,
variables and
yeah, definitely. So exactly that is the first approach. Travel through all the rows and count the number of ones in each row. And then at the end, like whichever row has the maximum number of ones, we can return that row.
yeah, yeah.
What is the time complexity in this? So you are running in
And
every row, and in that row you are going for every element. So this would be n cross m or n square if it is a square matrix, right? Because we are
yeah,
visiting every element once to check. Okay. Second approach, like which takes the benefit of the information that is given to us in the question. We are given that each row is sorted, right?
yeah,
So instead of like calculating all the number of ones, what I can do is I can go to the first row, and as soon as I get the first one, I do not need to see after this, right?
yeah. It's already
After this,
sorted.
because everything
Okay,
would be one
they're all
after this.
ones.
Yeah.
Yeah,
So let's say I go to the first row and I see that on the second column in the first row, I get a one. So right now I am at the second column. Then I go
yeah,
to the second row and I see that I do not get any one before two, right? Then I would go to the second row and I would see that, okay, here again, I get a one. The first one that I get is in the second column. And finally in the third row, I get one in the first column. So now this three would be my answer. I would update my answer. So the second approach is find row with least index of one. So that in whichever row I can find a one earliest, right?
yeah.
I would return that row. So this is the second approach, but have we improved the time complexity? So let's try to look
I
at
don't
it.
think so.
Let's quickly look at it. In
Still,
the
we are
worst case,
actually going through. Still, we are going through every rows.
yeah, we are going through every row, but we are not going
Rows.
through every column.
Every
In
yeah, every
Yeah,
column.
we are going through every row. So in first row, I would check as soon as I get the first one in this row, I would not need to look at the
The rest of
columns after it. Then I would go to the second row, and as soon as I get the first one, I would not look at it. So in this case, I'm not looking at all the elements, right? So it seems like this is a better approach because in the first case, I was calculating all the ones. So I was
yeah,
looking
we're
at
actually
every
counting
element,
all the
but in
ones.
this
Yeah.
case, we are not looking at all the elements. But what if this is the matrix that I get? In this case, if I use the second approach, it would again be order of n cross m. Because in the worst case, I would be going
Yeah.
to the first row and I have to travel through all the columns. In second row, I again travel all the columns. The way we calculate time complexity is actually by seeing the worst case. So worst case here is again n cross m. So we have not optimized the time complexity. Now let's try to look at the third approach. We have discussed binary search in the first class, right? If you remember.
I have taken the class two
No
days
problem.
ago.
I think you have to do some
2 days
revision.
ago, I have taken the class. Yeah, 2 days ago.
Yeah. So third approach is a little better. So what we can do is
Locating the meat and
one, let's say this is 0, 1, 1, 1, 0, 1, 1. So there is one condition. If that condition is matched, only then we can use binary search. And that condition is the array should be sorted in order to use binary search. So in this case, because it is given to us that all the rows are sorted, what we can do is we can go to the individual rows and we can apply binary search in them to find the first one in those rows. Right? So what is the time complexity of binary search? It is logN, right? I can find the first one in each row in logN time. So what is the time complexity now? It is n logN. Each row takes logN times, and there are n number of rows. So it is n logN time complexity, which is a better time complexity than n cross m or n square. But there is a better approach than this also. Like we can further reduce the time complexity, and this is the most optimized approach. So now let's look at this. So there are two information that are given to us, right? First information is that it is a binary matrix. So there are only ones and zeros in this matrix. Second information is each row is sorted. Is sorted. We try to take advantage of these information to find the most optimized solution. Let's take an example again. Let's say this is the matrix that is given to us, and these are the indexes. Let's try to observe how we can find the solution. Let me say that I am traveling through the first row, and as soon as I get this one, right? So in the first row, I have traveled this much, and I've seen that, okay, this is the first one that I have as of now. Now I would directly go down from here. I would keep a counter on which column I am right now. And as soon as I get the first one here, I would increase the row and I would be on the same column, which I was in the previous case. Okay, so now I see here, if I do not find one here, if I see that here it is 0, I do not need to look at this row anymore. In just one look, I can skip this row. Because my answer, I would also keep an answer variable, and in this case, my answer variable would be whatever the index here is. Then I would come here and I see, okay, I get a 1 here. So if I get a 1, now I would move left and I'll check, okay, I get another one, then again I would go left. Okay, now I see that I get a 0. So I would go down here. I see, okay, I get a 1, then I go here, then I go here, and I get a 1, and I would run it as long as the j is greater than equal to 0. Right? Now I go down, I see it is 0, so this would be my answer. This would be my result. Right? So let's try to write the steps, and would look like have we optimized the solution or not. So first step would be we will travel to first row to find in which column, like in which column do we find the first one. First one occurs. We would keep track of an answer or a result variable, update our answer variable to this, because right now my maximum answer is this, right? Then what I can do is in like I would also keep track of the column. So then in that column we will go downwards.
Can increase the
increase the row, keeping the column same, and you check whether it is a 0 or 1. So if it is a 0, if at this place
You can skip what?
If we find 0, we can skip the row,
Yeah.
because definitely if like the number of ones in this row would be smaller than what we had
Yeah.
previously.
Yes.
So in the next step, now what we are going to do, if there is a 1, if we find a 1 at that place, then we would
Increase the column, I think.
decrease the column. So we would
Decrease
move
the
towards
column.
left.
Yeah. Yeah.
We
Decrease the
would
column.
move to left in the row until we hit a 0. As soon as we hit a 0, now we would again go down.
We have to
Downwards.
update our answer, I think.
Yeah, update our answer as well. Right. Go downwards. And we like this is what we're going to do, and we would be keeping 2 base conditions to keep track like how long our loop would run. One would be that we keep going down until I is less than n, right? This is our row count.
You mean the rows?
And
Yeah. Rows.
yeah, we keep going left until j is greater than or equal to 0. So these are clear. Let's now try to write the code. Let's say my function is known as max once, and I'm taking a matrix as an input. First, I would calculate the number of rows, which would be n dot length. The number of columns would be a0 dot length. The result would start with 0. No, let's say in the worst case, there is no 1 in the array. Now we can start our for loop. Like my first condition is met here, right? Which was that you would go down until I is less than n. Now second condition is we would go left until j is greater than 1. But here we cannot run a nested loop, and I'll tell you why. Let's first try to write it. J greater than equal to 0. We'd run the inner loop as long as j is greater than equal to 0. What would be the first value of j? It start with the n. So j would be m minus 1, whatever the number of column is, minus 1. Okay, so as long as j is greater than equal to 0, now if a of I comma j is equals to 1, what we would do is I would decrement my j variable, so I would move towards left, and I would update my result variable, because I is the row that I have to return. And if I do not found a 1, as soon as I found a 0, I would break out of this while loop, so that my I could increment.
Okay.
Yeah, and finally, after the for loop is completed, I can return my result. This result would contain the row
The index, zero
index. Yeah. So I would give you a minute to look at this code. If there are any doubts, you can let me know in this code.
No, I don't have anything. Okay.